Hi guys, welcome back to the channel. Jag here. In today's class, we're going to continue with our Science 10 content and we're going to cover some more equations and we're going to focus today on the synthesis reactions. All right, so with that, let's get started. Okay, so here we are. Okay, so we have some synthesis reactions that we're going to go through here. Okay, remember when you have a synthesis reaction, okay, that basically means you have two or more reactants. So say I have A plus B like this, and it's actually going to form just one product. Okay, so the product here is going to be AB. Okay, so we are going through just some general terms here. Okay, it is easier for some students to kind of visualize what the product and the reactants are. So let's do a simple example here. Okay, so complete and balance the following synthesis reaction. So say I have sodium, okay, plus chlorine gas. Okay, so for those of you who are not sure, okay, I have to indicate the states here, okay? So the S here basically means the sodium is like a solid metal, okay? Chlorine is a gas, okay? The reason it's Cl2 here is because chlorine is diatomic, okay? Which means you have two molecules of chlorine that are attached together, or like two atoms. And that's how chlorine is found in nature. Okay, so I would remember all of the diatomic atoms. This includes chlorine, fluorine, hydrogen, bromine, mainly all of the halogens, okay, which is again group 7 or group 17 in the periodic table. So say we try this reaction here. This is a synthesis reaction. I noticed that the sodium and the chlorine are just combining together. And it's going to form, so we're just going to write Na and Cl together like this. Okay, make sure you check the periodic table. So as soon as I write the product, I want to check the charges. Sodium has a charge of 1 plus, chlorine has a charge of 1 minus. Okay, I notice in this case, both of these charges are just going to cancel each other out. Okay, and so we don't need to do the crossover method here. I'm only forming NaCl. Okay, does everyone see that? NaCl is actually table salt. Okay, the one that you use when you're cooking food in the kitchen. And that's why I know that it is a solid. Okay, and the next thing we have to do is make sure we balance the equation. Okay, so if I look on the left side here, I have one sodium atom. On the product side, there's also one sodium atom. However, if you look at the chlorine, I notice there are two chlorines, okay, on the reactant side. But on the product side, I only have one chlorine. So what we're going to do is put a 2 in front. Okay, make sure you leave some space here. And as soon as I change this, I notice there are two chlorine and there are two sodium atoms. And on the left side, I'm going to put a 2 in front of the sodium. And now there are two sodium atoms on both sides. And there are also two chlorine atoms on both sides. Okay, does everyone see that? All right, so good. Okay, so this time I'm going to put the example here. Okay, and I'm just going to write this in words. It says complete the following word equations and write and balance the formula equation. Okay, so let's write the word equation. So say I'm doing calcium, okay, plus oxygen. And this is all the question gives you basically, okay? So we're taking some questions off of this worksheet, which are some really good examples. So when you combine calcium and oxygen, this is a simple binary compound. So again, remember when I'm combining them, you keep the metal the same, so calcium. And for the non-metal, I'm going to add IDE. So this becomes calcium oxide. Does everyone see that? Okay. And now we're going to basically add, so I won't put the states here. Let's just put Ca is calcium plus oxygen. Okay, so again, oxygen is also diatomic. So we're going to write O2. And what we're forming is calcium oxide. So I'm going to write Ca and O. You're just combining them together. Again, as soon as I write the product, I want to write the charges. So check the periodic table. Calcium has a charge of 2 plus. Oxygen has a charge of 2 minus, okay? So one more time, I notice that both of these charges are going to cancel out. This is actually how you write the formula, okay, for calcium oxide. So one more time, make sure when you balance the equations, take a look at the number of atoms here, okay? There's one atom on both sides for calcium, two atoms of oxygen, okay, on the reactant side, but there's only one atom of oxygen here. Okay, on the product side, so I'm going to put a 2 in front. Okay, remember again, you can only put the coefficients in front, okay, of the element or compound. I can't put it in as a subscript. Okay, the reason for that is, again, it's just going to change the composition of the actual compound. Okay, so as soon as I put a 2 here, there are 2 oxygens, but there are also 2 calcium atoms, okay, on the product side. I notice there's only 1 calcium atom here, so I'm going to put a 2 in front. And I can see that balances everything out. Okay, so now there are 2 atoms of calcium on the reactant and product side. There are also 2 atoms of oxygen on the reactant and the product side. Okay, does everyone see that? All right, so good. Let's try another example here. Okay, so this looks like it is a transition metal. Okay, so let's try this one. So I have copper plus sulfur. Okay, and what it's forming. So I noticed that copper is a transition metal. So remember when we were discussing this in the previous video, it has 2 charges. Okay, so in this case, it can be 1 plus or 2 plus. In this case, let's try 2 plus. Okay, so if this copper has a charge of 2 plus, I'm going to put copper 2 and then sulfide. Everyone see that? Okay, and again, the teacher will just indicate, okay, what the actual charge is on your transition elements. Okay, and just go with that. Okay, so now we're going to write the actual equation out. So I'm doing copper, okay, plus sulfur. So we'll just put S here. Okay, although the actual form of sulfur, that is the most stable form in the atmosphere, is actually S8. And there would be like a subscript of 8 here. Okay, and so let's do what it's forming here. I'm forming copper, okay, and sulfur like this together, and it's forming copper 2 sulfide. That means copper has a charge of 2 plus, okay, and sulfur has a charge of 2 minus. And one more time, okay, they're basically going to just cancel each other out like this. And I'm just going to leave my equation like this, okay? So I notice everything is 1 to 1 here, so I don't need to balance anything out, okay? And again, if you do use sulfur as the S8 form, so we'll just put S8 here, it would actually be as a subscript like this. I notice I have to put in 8, so I have 8 atoms of sulfur, and I'd also have 8 atoms of copper here, okay? And so I'm going to put 8 in front of the copper. And now the copper is balanced on both sides. There are 8 atoms of copper, okay, on the reactant and product side. And then there are 8 atoms of sulfur on the reactant and product side. Okay, are there any questions here? That looks good. All right, so let's go to the next example here. Okay, so this example is going to be like a common example that you will see. Okay, most likely in the lab. So let's try this. So it's calcium oxide. Okay, so this is a metal oxide. Okay, I'm combining this with water. Okay, and so there should be actually like a reaction that you memorize. Okay, so calcium oxide plus water, or any metal oxide plus water, it forms the metal hydroxide. Okay, so this is going to form calcium. I'm going to write it right here, hydroxide. Okay. And again, the teacher will try to trick you. I would make sure I just memorize this equation. Okay, so let's try writing it out. So say I have calcium oxide. Okay, I can check the charges again. Okay, so remember calcium is in group 2, so it's 2 plus. Oxygen is always 2 minus. So again, I notice they just cancel each other out. Okay, so the compound formula is just going to be CaO plus water. Okay, we should all know what water is. Water is H2O like this. Okay, and what it's forming, we said, is calcium hydroxide. So calcium hydroxide is OH, okay, like this. So again, remember calcium, the charge is 2 plus. OH has a charge of 1 minus. Okay, I'm going to cross over the charges. Okay, and everyone see this? This is a 2 plus charge. It's being crossed over to the opposite side. Remember, we have to add the brackets around the OH. This one is actually going between the Ca and the OH. Okay, but I don't need to indicate that. Okay, so we're just going to leave this the same. Does everyone see that? Okay, and it's just forming calcium hydroxide like this. All right, so with that, let's go to the next example. Okay, so one more time, make sure you do memorize that equation. Okay, the next one is hydrogen. And we're going to add hydrogen plus nitrogen. Okay, and you might notice even if the teacher just gives you part of the word equation like this, make sure you can also start writing off the skeleton equation if you like, okay, just to see what's actually forming here. Hydrogen plus nitrogen is forming a compound known as ammonia. Okay, I do want to write the equation out first, okay, because you might think you have seen this before. Okay, so when you write out the equation here, okay, notice hydrogen and nitrogen again are diatomic elements. Okay, you have to put the 2 beside it or it's considered to be wrong. What is forming here is ammonia. Ammonia is NH3 like this. Okay, remember not to confuse this with ammonium. Okay, so ammonium is a polyatomic ion with a charge of 1+, but remember ammonium is NH4. Okay, ammonia is NH3. Okay, so sometimes students get confused there. Okay, make sure you keep both of those separate. So let's take a look at the balancing here. There are 2 hydrogen atoms here. And on this side, I noticed that there are 3 hydrogen atoms. Okay, so if you notice it's like an odd number like this, okay, you want to make sure that you are trying to balance it using some even numbers. So I'm going to put a 2 in front. So now I have 2 times 3. There are 6 hydrogen atoms on the product side. And how I can balance the 6 is by putting a 3 in front of the hydrogen. So 3 times 2, there are 6 hydrogen atoms, okay, on the reactant side. Does everyone see that? If you look at the nitrogen, I have 2 nitrogen atoms here, okay, on the reactant side. Because we put a 2 in front here, there are already 2 atoms of nitrogen, okay, on the product side. Does everyone see that? All right, so that's all you're doing here, okay, in terms of balancing the equations. And you can just leave your answer like this, okay? So with that, let's try one last example. Okay, so I'm going to maybe just write it on the bottom here. So let's try hydrogen. Everyone can see that. So we'll do hydrogen plus, say, chlorine. Okay, so we are trying a lot of these elements which are diatomic, okay? That way you actually remember to put the 2 beside it. Okay, if you don't put the 2 actually for diatomic elements, you won't be able to balance out the equation. Okay, so this is hydrogen plus chlorine, and what it's forming again is hydrogen chloride, okay? And for the non-metal, okay, I want to make sure that I'm actually putting the IDE, okay, at the very end. So let me just change that, okay? So we're forming hydrogen chloride. Let's write the skeleton equation. So that's the word equation. Okay, so what we're going to write here is H2 plus chlorine like this, okay? And what it's forming is hydrogen chloride. So HCl, just like that. Okay, and one more time, I notice here I have 2 hydrogen atoms. I have 2 chlorine atoms, okay, on the reactant side, but on the product side, there's only 1 hydrogen and 1 chlorine atom. If I put a 2 in front like this, I notice now that I have 2 hydrogen atoms and there are 2 chlorine atoms. Okay, so every time you're putting a number in front as the coefficient in front of the compound, make sure you're changing the number of atoms for each of the elements in that compound. Okay, does everyone see that? And that's basically what synthesis reactions are. Okay, so again, I'm just combining maybe like 2 elements, or I can combine an element and a compound together. Okay, and just remember that it's forming only 1 product, okay, at the very end. And that's how I know, okay, that it is a synthesis reaction. Does everyone see that? we're only forming one product. Okay, but for the reactants, it doesn't matter. It doesn't have to be like two elements like this. We were adding copper and sulfur. But if you look at this example, I was adding copper or calcium oxide plus water. So both of these are actually like compounds. Okay, but what it's forming at the end is going to be just one product. Okay? All right, so that looks good. And if there are no questions, that does bring this video to an end. Thank you so much for watching. Please make sure you do like, share, and subscribe to the channel, and I will see everyone next time. Thanks. Bye.